Testing. Let me slowly move into the camera. Well, okay. This is not me, sorry. It's wrong one. This is not Ida. Great, that's me. Good. So I'm gonna start this video with several questions about this disease. What would happen when a disease can spread within a certain amount of population? What if we know the original number of infected people and suspected people at the very beginning? Would that be possible for us to foresee the change of numbers of infected people during a certain time frame? And what are those papers saying by using what they call SIR or SEIR model? Does that model mean that was the extremely accurate result? If it's not, what are the constraints for the application of those models? Okay, now we're going to see whether it's possible for us to try to understand how the basic epidemic model was made. Assume that the total number of the population is n. The number of suspected people was s. The number of infected people was I. And what is happening in between s and I is that the suspected, because of their contact with the rest of the people, they are becoming infected through time. So let's see how the model can be made. Little bit adjustments. Does it work? Yeah. So the total number of n can be divided into I infective and s suspected. And normally they have a recovered amount of people, but to simplify the model at this stage, we assume the recovered is 0, meaning that it's really hard and there's no chance for them to get recovered. I know it's really cruel, but for example, this kind of model we call SI model can be applied into the HIV virus. Let's see. Then we're going to also define at the same time two parameters. We define the number of contacts that each infected people can approach per unit time as gamma. Meaning that for each one of the people in the infective group, they can approach this many people from the suspective guys. And then we define another. We define the probability of disease transmission per contact. Remember, per contact as beta. What does that mean? Meaning that for each contact between the infected people and suspected people, the success rate for the suspected people to become infected is beta. Well, I know it's really hard to pronounce, but anyways. So, what is the correlation of the number of the two groups, S and R, since the R is 0 now? Let's see. By the definition of gamma and beta, for each of the one person in S, let's say each one person, the possibility of their meeting infected people is S divided by N, right? It's I divided by N, right? For each person in S. Like if they meet another one guy, the possibility of this guy becoming the infected group is this. So, while we define the number of contact per unit time as gamma, and the probability of disease transmission was beta, then for this number of person, then the number of person of each one in the suspected people may lead to this times this amount of people to get infected. Well, it's per unit time, right? We remember this. So the total number of people in suspected group is S, so that we know one person can lead to this amount of people get infected per time. Meaning that if the total number is S, so we have to time S, meaning that the total number of people can lead to this amount of increase in the I per unit time. Meaning that the changing rate, like the speed of raising of I equals S times gamma times beta times I divided by N. And in this case, we know that N equals I plus S. Then we got the number equals, well, let's use all, like the right, left and right all use I. So N minus I times gamma times beta times I divided by N. We know that these are all constant numbers within a certain time frame. So we get the number, the changing speed of I equals N minus I times another constant. So in this case, we find a correlation of the I, which is using differential equations. We know that di dt equals N minus I, and then a constant, we call it gamma beta divided by N, and also times I. That's how they get to this step. So remember, their all of their assumptions. A fixed number, they divide into this two, and then the recovered is 0. Then we got the SI model. So what do? We give these models to mathematicians, and they will tell us how the function I in relation to t was going to be like, which is kind of like this model. If we got time, or more importantly, if I got the knowledge to understand the mathematical problems, we can try to infer from this step to this step. But now that's approximately the basic understandings of SI model. That's it. So yeah, thank you for watching. And yep, so see you next time. Bye-bye.